why do we care about ionization energy and electronic affinity? Well, in chemistry, we care about ionization energy and electronic affinity because it tells us when you have two atoms how likely they are to make an ionic bond in which electrons are exchanged. How likely is for one of the atoms to lose one electron and become positively charged, and for the other one to gain one electron and become negatively charged. And how likely it is for an atom to maybe not only lose one electron but lose two electrons, and how likely it's for another atom to gain maybe not only one electron but two or three. When you have an atom that has a huge tendency to become negatively charged, so has a large electronic affinity, meet an atom that finds it does not require a lot of energy to lose an electron, to become positively charged, then you have the perfect combination to have an ionic bond. And the poster elements for that are, for example, alkalines, like the group of sodium, lithium, sodium, potassium, etc., and the groups of the halogens, fluorine and chlorine, bromine, iodine. Alkalines, for example, sodium you need a very low energy to take an electron away, and chlorine releases chlorine and fluorine, iodine, bromine, halogens have a huge, liberate a lot of energy when gaining one electron, and you have the perfect combination to get an ionic compound. And you do get that, the sort of exchange of one loses one electron, the other one gains it. In most of the cases, the energetic configurations do not work so well. So the ionization potential is maybe okay, but it's a bit too high, so it's not that easy for that atom to become positively charged, or the electronic affinity is not too large. So yes, maybe some energy is liberated, yes, energy is liberated, but not a lot. Then it doesn't work so well. So the whole energetic, okay, let's exchange electrons. I lose an electron, you gain it, you liberate all this energy, and you give it to me, so I can continue losing, so I continue losing electrons, do not work so well. And that is when electrons, instead of all this whole thing, I lose an electron, you gain it, they prefer to share their electrons. And that is what we call a covalent bond. And in many cases, you have a sort of mixture of, we create these two buckets, ionic and covalent, to make our life easier. In practice, elements react and they make compounds, and they react depending on energetic configurations, but in many cases they will not fit neatly into the sort of you are ionic and you are covalent. In many cases they will, but in others don't. And you might have covalent compounds with a strong ionic component, or you might have ionic compounds with a strong covalent component, in which a compound is ionic, but it's not as ionic as a compound in which the energetic considerations work better.